In this lecture for S2 Business Mathematics for CA and Corporation, we are focusing on set theory. We are focusing on set theory. A set is a collection of well-defined objects, and members of the sets are called elements. So what do you mean by well-defined? Well-defined means the object follows a certain rule. Object follows a given rule or rules. Given rule or rules. For example, let's consider an example. A set A containing elements 1, 3, 5, 7, 9. So the general rule is we can consider that A is a set where these elements are set of odd integers less than 10. We can consider A as a set of odd integers less than 10. Okay, so well defined means the object follows a given rule or rules. So that is the given rule, the odd integers less than 10. Now, we can represent sets in two ways. Representation of sets. Representation. So representation of sets consists of one in tabular form. Tabular form means we'll represent an element A is equal to set 2, 4, 6, 8. Means the set of all odd integers less than 10. Okay, that is a tabular form. Now we have set builder form. We have set builder form. Set builder form means the same set can be rewritten as A is equal to X such that X is an even integer less than 10. That is called a set builder form. We specify, we write some specific property of element in the set. That is, X is an even integer less than 10. Okay. Now, let's see the types of sets. So, the types of sets. The first one is null set or empty set. Null set or empty set. So it basically denoted as either 5 or null. This is null set. But if you are writing a set like this way, this is not equal to 5 or empty set. So null set means a set which does not have a common element, or a set which does not contain no elements is called a null set or an empty set. Now let's see what is a singleton set. Singleton set. Singleton set. Singleton set means a set contain only one element. This is no elements. Set containing no elements. Whereas singleton set means set contain only one element. Set containing only one element. Set containing only one element is called a singleton set. For example, if I say A is equal to 2, 4, 6, 8. And B is equal to, I say, 2, and I asked you to find the intersection of A and B. The common will be 2. So this can be a singleton set. So the set contain only one element is called a singleton set. Now we have finite set. Next we have is finite set. So finite set means a set with a finite number of elements. Finite set with a finite number of elements. Is called finite set. For example, we can say 6, 7, 8, 9 and 10. So this is an example of a finite set. So the number of distinct elements in a finite set is the cardinal number of this. So if we are asked to find the cardinality of this number will be of 1, 2, 3, 4, 5. So number of elements will be 5. Okay, that is finite set. Now let's see what is infinite set. Infinite set means infinite number of elements. It will be having infinite number of elements. For example, we can say set of all real numbers. Set of all real numbers. Set of all real numbers is an infinite set. Now let's find what is disjoint set. Disjoint set. What is disjoint set? Disjoint set means two sets with no common elements. No common elements is called a disjoint set. A set which does not have no common elements. For example, A is equal to 3, 7, 5 and B is equal to 1, 2. So this is a disjoint set. There is no common element between these. Now we have equal set. Equal set means the two set with all elements common to both the set. So we can say A is equal to 4, 3, 2, 1 and B is equal to 1, 2, 3, 4. These are equal set because even though the order changes, the elements are the same. So we can say that A and B are equal sets. Equal set means two sets with elements common to both the set. Then we have equivalent set. After the equal set, we have equivalent set. Equivalent set means two or more sets are equivalent if they contain same number of elements. So two or more sets are equivalent if they contain same number of elements. For example, I represent A as E, F, G and H, whereas B is equal to 1, 2, 3, 4. So here the cardinality of this number is 4. Here as well as the cardinality is 4. So the same number of elements present in both the sets. So we can say that it is an equivalent set. Now we have subset. For subset, we'll consider before moving to definition, we'll consider an example. So let A be 1, 2, 3, 4 and B be a set which consists of 1, 2, 3, 4 and 5. So we can say that A is a subset of B. because a set is a subset of another set if every elements in the former are present in the latter. Every element in the former is present in the latter. You can consider 1, 2, 3, 4. So A consists of elements 1, 2, 3, 4, which is also present in the set B. So if that condition satisfies, we can say that it is a subset. Now next is universal set. Universal set. So universal set means the set which contain all sets under consideration as subsets. The sets which contain all the sets under the consideration as subset is known as universal set. For example, let's see A is equal to 3, 4, 5 and B is equal to 1, 2. Then we have another set 0, 6. So if we are asked to find the universal set, means the set consists of 0, 1, 2, 3, 4, 5 and 6 is considered as an universal set. The set which contain all the sets under the consideration of a subset is known as universal set. So universal set consists of all the elements. So it consists of elements 3, 4, 5. It consists of elements 1, 2 as well as it consists of elements 0 and 6. That is what a universal set. Now let's see what is a power set. So next one is a power set. Power set. So power set means a collection of all the subsets of a set is called a power set. Collection of all the subsets. Collection of all subsets. Collection of all the subsets of a set. Collection of all the subsets of a set is called a power set. Let's consider A as X and Y. The power set of this set will be, initially it consists of an empty set. It consists of a set X alone, a set Y alone, and a set consists of X and Y together. So the number of elements will be 4. So power set can be calculated as number of elements raised to n. 2 raised to n. So we have 2 sets, so it will be 2 raised to. If we have x, y and c, then that particular set will be, power set will be 2 raised to 3, that is 8. Okay. So this is how we consider the power set. Now we have complement set. Complement set. Complement set means a given set of elements is a set that has all the elements that are not contained in the given set. All elements that are not contained in a given set. Complement means. So if I say A is all the positive number, if I say all positive number, A is all positive number, then A complement means all negative number. All negative number. Okay, A will be a set with a all negative number. This is what a complement set. Now, the last of this lecture will be of operations on set. What all operations can be done in a set? We have union, we have intersection and set difference. So these are the operations. So we have union, intersection and set difference. So let's consider this with an example. So let A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 6, 8. Okay, so for example, you have given a set A 1, 2, 3, 4 and B 4, 5, 6, 8. If you are asked to find A union B, means all the elements of A as well as all the elements of B is called union. So it will be 1, 2, 3, 4 as well as there is a 4 already written, so you don't have to repeat the 4 again. So consider the rest of the elements. So it will be 5, 6 and 8. This is known as A union B. So when you consider the Venn diagram, so this is A and this is B. So the collection of all elements will be A union B. So elements of A as well as elements of B. Now let's see what is A intersection B. Intersection B means we look for the common element. So here 1, 2, 3, 4. We have only one common element, that is 4 in both the sides. So we'll write set 4, which is a singleton set. So in Venn diagram, we'll represent the intersection point, that is the midpoint, intersection points of both the set. So that is what A intersection B. Now, set difference means A minus B. A set consists of 1, 2, 3, 4. From this you are subtracting the element which is included in B. So you will write the set as 1, 2, 3. Because 4 is included in the set B. So if 4 is included in set B, you don't have to consider that element. And not always A minus B will be equal to B minus A. So if I say B minus A, I'll look for all the elements of 4, 5, 6, 8. And from that I have to separate the elements containing in B. So here also the 4 is present, so I don't consider the 4. So the set will be 5, 6, 8. So A minus B won't be equal to B minus A. So these are the operations on this set. So in this lecture, we learned about what is a set. So set means it's a collection of well-defined objects and members of the set are called elements. Well-defined means these objects follows a given rule. And the representation of sets can be carried out with a tabular form and a set builder form. Then we learned about different types of sets. So the first one was null set, means if the set which does not contain empty set or a null set, no elements. A set which contains no elements is called an empty set or a null set. It is denoted as a phi or set. And we have singleton set, means set containing only one element is called singleton set. Finite set means set with a finite number of elements like 6, 7, 8, 9, 10. Infinite means set of all real numbers. It means a set with an infinite number of elements. Then we have disjoint set, that is two sets with no common elements are called disjoint set. Equal set means two sets with elements common to both the sets are called equal sets. And the difference between equal sets and equivalent sets is that equivalent sets, two or more sets are equivalent if they contain the same number of elements. Then we have a subset. Subset means a subset of another set if every element in the former is contained in the latter. Then we have universal set, the set which contain all the sets under the consideration of a subset. Then power set. Power set means collection of all the subsets of a set, which is found with the equation 2 raised to n. Then the complement of the set. If I say A is all positive number, the complement will be other than positive number, which is negative number. Then the operations on the set, we have union, intersection and set intersection. So union will be represented as U and intersection as this way, and set difference means with a subtraction. This is all about set theory. Hope it is clear for you, and thank you.